Well, hi, good morning. Thanks so much for coming and keeping me company here while I slug it out with this radio. Today is December 4th, 2022. Now, what is going on with this radio? That's my question. So in the last video, I seemed to really, I don't want to say pinpoint, it's not quite the right word, but focus the problem right down on this tube. This stage right here is the first stage in the radio. And here's the situation. It appears as if the antenna signal is present in its proper form on the grid of this tube. But it appears that there's nothing on the plate. The tube itself is okay. I've had two tubes in here, both tested good. Both are in here, both have been in. Makes no difference which one I use, I get the same result. Not the tube. I've tested the pin resistances, they're okay. I've tested the tube voltages, the plate, the screen voltages, they're okay. Everything appears to be okay, but it's not okay because it's not working. So that's where I'm at. Usually in a situation like this where things get really weird, where pretty much you've exhausted all the reasonable possibilities, then you're left with something very unreasonable. And what would that be? That would be a stupid soldering thing here, a blob of solder getting somewhere shouldn't get to, a cold joint that's not obviously a cold joint, a component that's not correct. I've replaced these two capacitors and this resistor here. Again, two pin measurements are correct. This resistor is correct. Everything is correct, but nothing is working. How can this be? How can this possibly be? So, I don't know. If I knew the exact answer, we'd be on to the next topic with this radio. The other weird thing is the higher frequency bands appear to work. But I think in that case what's happening is the higher radio frequency is able to kind of skip past the stage and get into other sensitive parts of the radio I'm pointing at where I think it is, and carry on as if it had come through the antenna when it hasn't. I got excited and thought maybe the local oscillator was missing. But no, the local oscillator is present. So what is happening here with this one tube? Well, that's a really, really good question. That's all I've got. All I've got is the question. How am I going to approach this now? Well, I've kind of done everything, haven't I? I'm going to have to go pin by pin. This is what most I can think of. Pin by pin, very carefully checking everything to do with that pin on the tube. How can this even lead to something? Hey, this is the fun part of doing this work. This is where the fun is really. It's really going here. The fun left actually. So. Okay, well, I really don't know what to do exactly, so I think I'm going to go and drink my coffee. It's cooled off now enough that I can start drinking it, and jazz up my brain cells for this. Jazz up. Okay, so the only theory I can come up with, and I'm just making this up, is somehow the grid on this tube is being driven way negative. And the result of that is the tube is in cutoff, or something like that. The gain of the tube has gone down to nothing. Fat chance on that happening, but I have found something quite interesting here while I was drinking my coffee and studying this schematic, which has come from this book, S-40A. Bearing in mind, this is a bit of a special actor here. He's got that meter stuck in the front, which I have not found any information about the meter stuck in the front. on any diagrams. And here's something else I think might be significant. You watch the grid coming out of this tube. It comes down this way through this little resistor here. This is a 27 ohm resistor. And then it ties back to the tuning capacitors and on its way to the antenna. So could it be the case that there's no bleed from this grid, that if the grid develops its own negative charge, and it's arguable about how that could happen, but let's say it did, where would that charge go? Well, assumably it would bleed off through all this. Or would it? Or is all this open circuit basically looking this way? The reason I raise this is because have a look at this other circuit diagram. I think I'm just going to... Oh, that's not going to work. I'll put it up on the screen here and we'll take a look at the same area. This is a later, I believe it to be a later version of this radio. So let's put that up on the screen here. So here's the same tube. There's the grid coming out. And wait a minute, what's this? Now, in the radio I have, I'm looking at the schematic, what happens here is the grid comes out, there is no resistor, there is no capacitor. It just goes straight down to here. And then off into the rest of it. And this could be the same here. This is not. This is dramatically different. This has a capacitor and has a bleed resistor here, 1 megohm resistor. My understanding of a resistor like this is its job is to make sure the grid doesn't drift negative. Get more and more negative and eventually cut the tube off. How does it get negative? Because of action in the tube. After all, the grid is dipped into a pressure of electrons inside this tube. It's just, pressure of electrons. You could push this negative. Literally, this is collecting some electrons. Without this resistor, even though it's pretty big, 1 meg, without it, they build up. Maybe the original makers of the radio didn't pay attention to this problem, the original designers, or they felt the bleed would take place through here, couldn't it? Couldn't it take place through there? Oh, that's interesting. So what's interesting is in the other schematic, assuming this one we're looking at is the newer one, in the older one, there's a capacitor here. It's not solidly grounded. So the difference here is they removed the capacitor from here, stuck one in up here. Now, doesn't this stop AVC? Let's follow this wire back. Where's it going anyway? It's probably going to go back. It's probably part, see here it's going up here, getting on another grid. So this is the AVC line. So in the other schematic, I don't think there's any AVC applied to this first tube, which is really quite odd. Unless they're sneaking it in through the bottom. They are. So on the other schematic, this wire is extended over here and actually attaches above the capacitor that's here. Capacitor blocking the little bit of biased DC that's on the AVC line. And then the AVC comes up through here and gets on the grid. There's something more going on here. So now, what have I got in the radio have I got version 1 with just a resistor, or version 2 with a relocated AVC feed directly onto the grid, capacitor moved up from here up to here. This resistor is essentially left alone, this small resistor. I think it says 22 here maybe? In the radio there's a 22 ohm resistor. There is no capacitor. There is no resistor. So it's following this other schematic. Well, what happens if the capacitor down here is not correct? That's a 0.05. Oh my gosh, is that capacitor once again that's down buried in the radio underneath these coils? Okay, we got a bite. I got a tug on the line here. That's fishing talk if you're not following me here. Okay. So there must be a capacitor going to ground. You can see it here. 0.05, number 27, attached to sort of the coil return, if you like. That guy, well, you know what? Maybe it's so leaky that it's causing these problems, and yet I've managed to do DC testing around it successfully. It is on the grid line. I've been looking at the plate and the screen voltage, not paying too much attention to the grid, because I thought I found the signal on the grid. I tested it here with a signal tracer right on the antenna, and then I moved the lead over here to test the grid right here. And what did I get? I got a stronger signal. I don't know what the bias is here. I don't know what's going on with the bias. They've made a change to this radio to correct a problem. And is the problem I'm having? Could it be so simple that burying this capacitor down here was the guys in the repair shop at the factory, because these things would be returned to the factory for repair, continually complained about this capacitor back here. You know what it takes to change that capacitor? Can't you do something else? Could have been other problems with running the AVC through all these coils. It's a cleaner arrangement the way they have it. So I could alter this radio to fit that, or see about that capacitor down there. Now, a leaky capacitor there? How could that drive a negative? It couldn't. It wouldn't help the tube go into cutoff, but I suppose it could drag down the. Well, if this capacitor has no capacity, then there's no good signal ground on here. This isn't going to work as well as it should. I get a suppressed or depressed signal level here. You'd still get something though. It seems extreme what's going on in this radio. It virtually goes dead at this point. Yet I measured a signal there. Didn't I apply a signal there? And find it couldn't get through? Once again, maybe it's, well, what if this is a short? Well, that's not the end of the world either. I mean, signal-wise, this is a short. It's a 0.05. You had an actual short there. You do away with the AVC. You would do away with the AVC voltage. You'd do away with the signal too. Maybe not. The signal's coming out the top of these coils. But you'd kill any DC that made it there. This is a 100K resistor here. There's usually no real good current supply, so I don't think it would burn up or anything. But maybe this guy is implicated too. Well, AVC is brought across on this schematic and the other. And we should see AVC action on this grid with the radio operating, feeding a signal in. I could always feed an IF signal in and really get the IF cooking. Generate an AVC voltage back, and then see if I can find it up here, or go after I got to go after this capacitor anyway. I mean, even though it's down under there. Now this is kind of weird how they've done this, because the capacitor body's down here. This is, I've looking at this before, but the lead is brought through on top of the radio and soldered right here. it doesn't even look like a regular wire. It looks like a braid. So we're really trying to ground it really well here. Why isn't the capacitor sitting here? Could be there isn't enough space. They couldn't fit it in up here. They'd rather have it underneath anyway, where it's a little bit protected. But there's another thing. There's this weird effect where charges in a spherical body exist on the outside of the sphere, not on the inside. It's really kind of weird when you think about it. Is this a sphere? I have seen cases where they have brought bare wires up through holes to solder them up on top of the chassis, rather than solder them on the inside of the chassis. And I kind of thought, and I may have read, that that's because of this charge on the outside of the sphere thing. But don't quote me on that one. Maybe they just discovered through empirical investigation it's better to do this than to do something else. The grommets here that are supporting this. Thank you very much for sending someone, one of you, maybe you, sent me an email with some articles, interesting magazine articles, mostly about the meter we'll eventually get to. And in there it mentioned the grommets here and described them as anti-vibration grommets. So the idea is if the chassis is vibrating, what would make it vibrate? The speaker would make it vibrate. The speaker's vibrating the whole cabinet, vibration going right up into the capacitor, going right into the plates. The plates are vibrating with the sound in the speaker, and you can guess what that would do. That would cause a feedback arrangement of some weird sort in a radio like this. So to lessen that possibility, and maybe even the possibility of you bang the radio and you're actually shaking the plates, they put some nice grommets here to kind of float this thing. Doesn't look very effective to me, but that's how they were described in that article. Not insulation, mechanical isolation. And that would explain why we've got these grounding things a little bit. Look at the grounding of this guy again. Too many wires on my bench here. So the grounding is done here. There's just a little short wire from a terminal on the screw here. And then underneath, when I looked at this before, it looked like it was just bolted solid. Let's go under there and take a look again. Hard to see what's going on here. Son of a gun. So I had my finger on that part, at the back here. It helped me locate it. And I would say it's right under this coil. I would say it's holding that coil in place. That's crazy, isn't it? That's crazy. Yes, I think that is crazy. I think we're above the coil. Yeah, I think I see the bottom of the screw there. And it's just coming through the metal. So the screw is coming through. Now a grommet could isolate it, that screw all the way through. But in the end it's going into a metal, just going into the metal here. I'm just looking at all these now. You need a special tool to get into these guys. A C, exactly. You need a C. I also read that all these coils, all these slugs are wax. I can see wax on this one. And the rest Looks like there's wax there. And they're way down there. If they even exist. Oh yeah, they're way down in there. Slugs are way down. Not this one though. Okay, don't worry about that stuff yet. Don't worry about that stuff yet. Okay, so best idea is try to measure the bias that's developing on this tube. This is a tricky thing to do. Usually the impedance of these circuits is extremely high. How to get so high? Well, you couldn't maintain a really high impedance if this capacitor is leaking. 100K, that's not terribly high. Let me go all the way back. And then we go up and over. Come up and over, we're here. Then we need some connections here. This is the last IF transformer. So, I mean, that's your classic, it's going here into the diodes. It's your classic AVC circuit, but the resistance is not that high on it. 47K there. There's a meg going down this way. I'm not sure what all this is about yet. Well, part of this, part of this. Wow, there's diodes everywhere. 1, 2, 3, 4. Diodes everywhere. So this guy comes back. And there's just the one resistor in line, 0.02 down here, 0.02, which I've changed. It just comes along. That's it, 100K. Often you find like 2 million ohm resistors in a circuit like that. In the remade circuit, it's 1 million coming off of here down to here, and they do away with this. There he is. I got to get that capacitor out of there. So just get it out, replace it as best I can, exactly as it is. Oh my gosh, how am I going to do that? Exactly as it is, eh? Up through the chassis and soldered up above. And then where's the other end going? The other end is... Oh my gosh, how am I... Yeah, I could see the repair guys going, this is crazy what you've done here. You've put a capacitor that we had trouble with in a very, very difficult location. How in the heck am I going to do this? Yeah, that's a good question. How are you going to do that? First, I'm going to go and drink coffee, because this is a real headache, this one. Okay, let's take a close look at things before I make a mistake. I want to make absolutely sure the leads, I believe, go to that capacitor, do go to that capacitor. So one of them, I'm pretty sure, is just coming right up here. And we're just going to take the other camera and take a look up there. Let's take a look here. So I got my finger on the wire. And that is it going up in the back to the capacitor. But do you see something else that's quite interesting? What's with that wire wrapped around there? What is going on with that? This is another sort of gimmicky sort of thing going on, I think. Just, hey, we got some excess wire, let's wrap it around there. That's not how that got there. Okay, so this is definitely the lead in this heavy cover. Why so heavy a cover on there, too? It's kind of odd. Okay, all things are odd about that capacitor. And it's pressed right down against the bottom here. Is that on purpose? They've got it right up against the cabinet. See outside foil is at this end. Wow. Okay, I think I've got a plan here on how to approach this. I think it involves me doing this off camera, because it's just going to be too awkward to try to do this on camera. I'm going to stick a 0.05 in there, like it or not. Okay, I cut the capacitor at the top, pulling it out. This resistor is getting roughed up here. Look at that. Oh boy, this isn't shielded, is it? Is this no, it wouldn't shield the ground wire. This capacitor has a special lead on it. What the heck? You know, all these things suggest, I'll bet you this is also braided. We just can't see it in through here. It's a special capacitor with a braided lead. Now, why do you braid these leads? Yeah, there's probably a couple reasons. I mean, obviously better. Well, it doesn't feel like it's really soldered here. No, it must be soldered. Okay. This is purchased from the manufacturer with these kinds of leads. Never seen this before. I thought I was going to find a capacitor with a regular lead coming out. Look, this isn't even in the center of the capacitor. It's off to the side. This is some special shielded guy. It's got a lot of writing on it. Okay, well, it's coming out, like it or not. I'm going to cut this about here. Yeah, shielded out of both ends. This is a super special capacitor. You know what that means? You can't afford any trouble on this guy, or a disaster. Wow, okay, I gotta get the other camera and try to read all the stuff that's written on here. I certainly don't have similar capacitors here. DC working voltage 200, not very high, 0.05, okay. Tubular paper capacitor. Ajax. Ajax is a city in not near Toronto, made in the USA. Ajax condenser, Chicago, Illinois. Capacity 0.05. Nothing. It's not saying anything special. You're not telling me anything special. So that leads in the center. This one's off center. Capacitor looks great. Okay, let's give it a test here. See what we got. Oops. Whoa! Camera just went flying. My camera cord caught on the tripod of this camera. Okay, lay your money down. What do you think? I think this is going to be as leaky as the rest of them. I think we'll see a leak at 50 volts. In other words, the eye here won't open all the way, even at 50 volts. Okay, my money's down, but I'm not going to tell you how much I'm putting down on this. Here it is. I got it right here in my hand. Here we go. Does he win? And the eye is just slammed shut. It's almost crying with pain. It's so shut. So that is quite the leaky capacitor relative to most. And how much did I bet? I bet 1 American penny. I have an American penny here. There's often lots of American change floating around in Canadian hands. It used to be the case a long time ago. Now it's not so much anymore. I don't really encounter it very much. Of course, a penny. We don't have a penny in Canada. We haven't had it for a long time now. No penny. No pennies. We still price things down to the penny. If you buy them, with your bank card, you pay to the penny exactly what the price is. If you pay cash, then there's a rounding thing that takes place at the cashier. Around, it's in favor of you, the buyer. So, because of five, you have 5. What are you gonna do with this one? Does it round up or round down? It rounds in favor of the customer. But that's how we handle it. No pennies. America, you can get rid of your pennies. It doesn't hurt. Okay. So there's nothing special looking about this capacitor except these leads again. Why would they do this? Why would they do this? Is it extra low resistance? I mean, how extra low can you go on a little piece of wire this long? Is that critical? Now I have an option here. Instead of putting this back in, I can take the other schematic and follow the other schematic. So I would put in my own, put a capacitor up here, and then run a 1 million all the way down to here. What happens with this little piece? Okay, so I got to think about that. Radically changing the design from what it is in the radio to something else. Who knows what other problems? There could be other compensatory actions that were taken I haven't recognized in making this change. Maybe even something way up in the radio somewhere I don't know about. So I could. The thing about doing it is I think it's all just done up here. It's not a big deal. Whereas putting this other capacitor in looks like a big deal. Braided wires. What could they be so worried about with this guy? I mean, what would happen? If the slightest resistance in the leads here? Of course, there is only a 27 ohm resistor here, so that's saying something about what a little bit of resistance can do. I mean, why'd they put this in here? 27 ohms. That's like putting nothing in there. But obviously it's something. There's some tremendous sensitivity to a little bit of resistance in this circuit. Sometimes they stick a resistor in like this to, it'll suppress oscillations. I don't know if that's what that's doing there. I mean, 27 ohms. How's that helping anything? Got 100K down here. It's 27 on here. It's 22 on the other circuit diagram. It's 22 in here. This is like some kind of a mixture of. Oh my God! This wouldn't be a prototype, would it? Is there a chance that this is a prototype? No, this can't be a prototype radio. The prototype being, this was put in and some other changes were made, and they built this in the factory, and then engineers sat around, played with it, and went, yeah, I don't know, because I haven't found any information about this being in the radio. Everything I found, the speaker is sitting here. But surely to goodness, this wasn't slapped together. It's got this nice emblem on it. It does have this really weird switch arrangement here. I think it's weird. It's like a lot more hardware than you might regularly need to do this. It's done with a lot of hardware in the back. I guess if you're going to prototype something, you want it to look like it's going to look when it comes off the assembly line. Pretty much. Nah, I can't be a prototype. If it's a prototype, then there's all kinds of things in here that might be done differently than any schematic. No, yeah. Well, and how is that going to help me? Okay, it's a prototype. Look, that helps? It doesn't help me. Well, I have to make a decision here. Either I just restore it with the capacitor down here, which seems like a fairly relatively easy thing, or I go ahead and do the fancy change. Coffee will help me decide. So from time to time I get concerned enough about the outside foil on my little yellow capacitors that I've been looking for a quick and dirty way to figure out which lead is the outside foil. It's not marked on these capacitors at all. You really haven't found anything too impressive until just now. So look, this is just my scope. Geez, I've got it on times 10 even. Here, I've got this is set as sensitive as it'll go. Now what happens if I grab the body of this capacitor? So if I grab the body, you can see if I put this on times 1. It was on times 1. I was wrong. Okay, so can you see I can't make this any more sensitive. You can see that it's wiggling a bit. I'm afraid it's not very good in this camera here. There, you can kind of see that there's like a 60 cycle hum running along there. Now I'm going to reverse the leads here. And now what do we get? Now when we look at it, you can't really see that. Okay, so we're going to go back. And once again, I can see the if we did like that, this is better. Okay, you can see that now. Okay, I will reverse the leads. If this works, this is great. Different ways I've tried to do this. There, but it's much less. Okay, so the more way was with the connection like this. This must be connected to the outside foil. Of course, I got the ground on there. This must be the outside foil. I'm going with that. The outside foil was coming back into the radio, wasn't it? So this has to go in this way, in like that. Okay, now I can't put this capacitor down. I'm going to forget. Don't forget. It's going in just like that. Okay. And I have some concerns about this, but let's see what happens. Okay. I think the best way I can do this is insert like that, and then try to make the connection up above, give the capacitor some stability before I try down below. Okay, I've got a grip on it. No, I don't. There. Don't fall out now. It's going to fall out. Taking my pliers through there. Okay, that's plenty tight. I need to push the capacitor capacitor down. Down against the deck. Bring the lead around here, up, hoping there's no small wires there. We're going to want to attach to this braid. And that should give me enough to push the capacitor right down against the chassis. Oh, I hope I got the outside foil right. I forgot about that. I forgot about that after all that nonsense. Want to do what's called a lap joint here, sort of, to give a larger surface area to solder against. I think that's a stupid idea, but that's what I got in my head. There, something like that. Have to be an intimate contact if we're going to solder them. Okay, it's coming along. It's looking pretty good. I think you can do that. Okay, let's give that a try. Could this be the whole problem? Yeah, this could be the whole problem for reasons I don't fully understand. But certainly finding this guy so leaky, really, and what else have I got? I've got nothing else. Got nothing else but this capacitor. Okay, let's see if we can do this. Fortunately, this wire's right in the way for your view. What I can do? Come up to my level. You can watch the exciting soldering process here. Lots of metal here to heat up. Not exactly an intimate contact here. Lots of solder. Not particularly good. That would be better. Yeah, that's good. That's a good soaking there. Okay. That's one side. That's pretty soldered. Okay, wasn't nearly as difficult as I expected. Maybe because I took my time and didn't. Okay, we're going to try now is operating the set and seeing if there's any difference. Volume's down. Plug is going into the isolation transformer. Just get a few tools out of the way here. This is set to medium, so it's ready to go. There we go. Okay, dim bulb's doing the right thing. See if anything else is doing the right thing. So we're on broadcast band, no antenna. Let's see what happens. Well, seems like it was. I want to put an antenna on. We will try, as silly as it is, we will try the outdoor antenna first. So the link is closed on the antenna. Put the ground in. Now, do we hear this? Oh, this didn't do anything before. Okie dokie. Now, can we pick up a station here? So, French station right around here. Not likely to picked up on the wire. You know, I don't know for sure this antenna is switched on. I'm going to have to run and check it. Line's up pretty high now. Hey, where'd all those, like, little heterodyne there? Where'd all that go? Okay, strongest station's right in this area. No. No, we're not going to hear anything, but the antenna is crummy. Okay, so I'm going to stop, rejoice at this point before I find out this didn't work. And I'm going to make sure the antenna's on too. Drink some coffee again. Okay, I skipped the coffee. So the antenna switch was on, so that outdoor antenna was connected. We didn't really pick anything up. I'm on the loop antenna now, and I need to tune it. So right around 590, which is where there's a strong station. Hopefully we'll hear it peak this time. Uh-oh. So no peak appearing. What happened? What happened while I was away? We're getting some effect here. Big effect from this. This is the outdoor antenna. Let's go back to that. We'll keep the ground off. Just hook it on. Oh, hot diggity dog. Yeah, believe it or not, that's a good sign. That's an interference that's typically around my house. Fantastic. How are we going to beat this off? Quicker, limiter. Oh! Of course, we have limited everything. Come on now. We'll pick up any station. Any station. To start. Yeah. Limiter off. Wow. Wow, does that ever do the job? And I was saying something about we don't have this kind of noise anymore because our cars don't make it. I don't know what this is. Wow, does that ever work? That's the first noise limiter. Well, maybe the first one I really had a chance to test. Now, what happens if I put the ground on? Did it just kill us? Kills it dead. Isn't that a little odd? It's definitely the ground tone, though. Can we retune it? It's a little surprising. Oh, wrong thing. I meant to turn the volume down. Anything else? No. What frequency is this? It could be 680. Nope. Could be 640. No. Could be 590. That's what it is. It's 590. Yeah, definitely. So 590 is the strongest station I get here. Why no action on the loop antenna? Well, I didn't really have it connected properly. Let's just give that a go, because it would be wonderful to hear this radio work quite well. So I need to open the link here, because the loop antenna is a balanced antenna. Okay, up the link. And this provides access to the top and bottom of the antenna coil without any ground involved. Okay, lead from there. Lead from this is the loop antenna. There's no polarity as such. I'm going to do it on the back here where I get a little better clipping. Okay, that's one. This is just a dumb wire antenna at the moment. But once I put this other one on, now I have an excellent loop antenna. I can hear the station too. Okay, fantastic loop antenna. Built out of broomsticks. Looking for a peep. There it is. Terrible. Gee, they pick up better from the wire antenna. I've never had that happen. Did we stop too soon? Reception's very poor. It's like that horrifying noise. Okay, maybe I can null it out by steering the antenna. Well, that's not terribly satisfactory. But it's all I got. Now, perhaps what's happening is bad alignment at this point. It's not terribly lovely, but what else can you do here? I don't know. So that's interesting. I just swung down the ground link. It didn't make any difference at all. So something that can happen to these radios that are depending upon an external antenna. Something bad can happen to that antenna. We saw there was a unpolarized plug here. Capacitor's weak and leaky. Is it just possible that somehow one of these coils got burned out? Like that one. Or this one, or this one, or this one. Burned out. You can see the wire from here come over and hit a terminal on this first. This is a transformer here. And the red wire continues on up here where it then splits out to the others. And that's the antenna making its way to each coil. Doesn't tell me which is which though. Now, is there a chance the capacitor that I put in is something funny about it? Is there something funny about it? It's not pushed right down, but I can't imagine that makes any difference. Hey, did I fix it? Gee, I don't know. Well, let's try sensitivity on other bands. So this one's not. A little hard to explain what just happened there. I disconnect the loopy part of the loop and get a better response. Going back to the wire antenna. The antenna link is closed on the back. Very distorted too. Aside from the noise, the interference. That's amazing. Needs adjustment for sure. ABC. Sounds like a tiny difference, but this may not be the right test for it. Okay, so we're going to go up and leave this on. Yeah, let's go see what we can find on the shortwave bands here. So we'll go up one band. That's pretty convincing. So we're not going to pick anything up here, I'm sure. This is 3 megahertz, 4 megahertz. We're not going to pick up anything at this time of day. It's just a funny sound. Hey, what's going on? I can't make it up. So it's a wire catching or something. Oh yeah, it's this thing. This thing. Okay, we'll switch up to the next band. Lots there. We're up at 15 megahertz going down. Beautiful. you stand a chance of seeing what's on the dial. Cover the light. $15 right here. It's a strong station usually at 15,770. I don't think this reaches it. Let's go down. Limiter off. Limiter off. Okay, CW on, UFO on. It's as low as I can get it that way. Teletype or something of that sort.
Todas las prescripciones de la clase media estadounidense, y sobre todo cómo debía ser el comportamiento de una mujer judía. Ella se enfrentó a todo eso.
I'm going to attach the ground here from the outdoor antenna. Sometimes this has dramatic improvements. Yeah, look at that. Yeah, that station's in two places. That's Radio Martin. What's going on there? That's an odd thing. Two. Oh. What is that? Some kind of a radar? Like an over-the-horizon radar? No idea. Oh my gosh. Wow, that's a new thing. Brothers there. What in heaven's name is that? Is that this radio? I'm going to change the input, the supply voltage. No, I can't imagine the radio itself is doing that. Turn on the BFO. Teletype. What the heck is that noise? Okay, CW off. What in heaven's name is going on here? Is this for real? Right around 9 megahertz. That's the strangest stuff I think I've ever heard. So I'm going to get this other radio going. 9 megahertz. 9,000. Ooh, yeah, it's there. It's not this radio, is it? Okay, cutting the power to the big radio. No, it's still there doing its thing. Okay, some weird new noise. It's reminiscent of my other computer, which when I put it on sleep mode, it issues a pulse every second. A loud RF pulse comes out of it, loud enough to be picked up in my car radio out on the street, out front of my house. It comes out of my other computer, which I never put on sleep anymore. Very odd. Get out of here.
Actually says reproached. Actually glorifying y'all when you say fake thing.
Straight across the whole band here. Really strange. What is doing that? Is it my soldering iron? Is it the lights? Well, I haven't got anything else going in here but this radio and my computer. Never heard this before. Stops. What ugly thing is doing this? Well, that's the capacitor. Okay, upper band, top band. Okay, so now we're starting up around 15 here. This is 15. Thought I heard a voice, but I guess it was the noise. Wouldn't this ruin my hobby? Okay, through the dirt. So I expect it stationed right in the dirt area, 15770, but it may not be there. Well, let's find out. Let's find out if it's there, because it's very strong. So go 15770. Nobody home today.
Camera I've got.
What's that doing up there?
It's by holding tithes and offerings. And because
This is 16. 600. There shouldn't be anything there like this.
And offerings unto the Lord, God says you are cursed. God
That?
says bring all the tithes
I'm cursed.
into the Lord's store.
Curse. A spell has been put upon me. Just super broadband interference. Won't they just go away? Can't get higher than this. The radio went dead. So these are very high frequency amateur radio bands right in here, but I don't know that they're active today. Well, they're active. The BFO is way out here. This has a nice weight to it. That's pretty surprising we picked that up. And from here, we're going 28 megahertz and above. There's nothing in here. I think this used to be police here for a while and stuff, in history. Well, that's interesting. Okay, enough of this. I dare say that's enough of that. Now I put a little plastic cup over the light. Did it melt onto the light? A little bit. Well, okay, so I'm going to declare that capacitor change as being the solution to the problem I was having with this radio. I'm going to declare success there and move on. So what's next? Two things. Continue with the alignment process or start fiddling with this meter. I could even do a preliminary look at this meter. Now it turns out, thank you for sending me some information in an email. Sorry, I can't think of your name right now, but you know who you are. You sent me a diagram that actually appears in here. You drew my attention to this diagram. So this reveals the secret of how they're making the meter here operate. Now, this is inside this box. You buy this box, and a cord comes out of it with a plug on the end, and you plug it in the back of the radio here, and presto, you've got a meter. It's hard to see, but there's a knob here and there's a knob here. This is very same. So I'm going to guess that this is exactly this, and we're going to get to it. For service of this item, contact the dealer from whom it was purchased. Be true of the radio itself. I just have to contact the dealer who sold this radio and ask him, hey, what's going on with this meter? Okay, I think that's it for today. I think that's all I'm going to do today. Tomorrow I will do more alignment work. We'll see if we can pick up the sensitivity of the radio more. And as I say, I'm going to quit now because now's a good time to go and declare success. Yeah, great. Thanks a lot for watching.